Okay, I'm really excited about this one. I'll share my screen and I'll be going over the Django app that I made that's deploying a machine learning model that predicts if someone's having a heart attack or not. And it doesn't look super pretty, but that's not the point of teaching myself this. I'm not teaching myself CSS and HTML, maybe later. So first of all, you just enter in the patient's vitals, and here there's descriptions of what exactly the data is. This is from the data dictionary. I have this one already filled out. So a 56-year-old male with chest pain type 3, resting blood pressure of this. Submit it. This also doesn't look great, but it works. Should the patient be admitted? 1 meaning yes. The likelihood that they're having a heart attack is 71.4%. And if we go back here, we can change this to 100. And then our results are still, they should be admitted, but the likelihood is only 7% that they are having a heart attack. And I'll talk a little bit more about why they're still admitted at 7%. I'll talk more about that later. If their chest pain type is 0, then they should not be admitted because there's only this much of a chance that they're having a heart attack. And I'll go over that code. I built it in Google Colab. And then deployed it in Django in VS Code. So first, I'll skip that. I did just some basic data exploration. Again, this is the point of this is definitely not data wrangling. The data is pretty clean, but I just did some exploring. There's no NA problems. Got some more information, made some graphs just to see. It's about 50-50-ish on people that didn't have heart attacks. The age of people that came into the ER. So this one's interesting. This one is, this column is women, or this row is women, and this is then this one's men, and this is had a heart attack, didn't have a heart attack. So you can kind of see some patterns there. Some other, I forget what this variable is. Then we just did a test train split right here. And double checked, looked at all the data, made sure that it looked right. We defined a model and fit it. So I started out with a decision tree. And then after evaluation, it was about 70% not accurate, because we're not going for accuracy. This kind of explains, if you want to pause it and look at this, this explains why we care about recall. We don't care about precision or accuracy. We want recall. If you had to mess up on one of these, you would want to mess up on this one and say, yes, we need to admit you, even if they don't actually need to be admitted. If you have to make a mistake, these two are right, these two are mistakes. If you have to make one mistake, this is an okay mistake to make. This one saying you're not having a heart attack, go home, is a bad decision to make. So we'll focus on recall. So the recall is about 70%. That explains a little bit more. So now we're going to try a logistic regression. So we'll bring in a logistic regression model and we'll fit it. And then here let's see, we're evaluating it. Much better, still not perfect. I mean, if 7% of people that come in die, that's not good. Or if you tell 7% of people that are having a heart attack that they're not, that's not good. So what we did, so a logistic regression takes a row of data and it it predicts a value between 0 and 1 of how likely it is that that person's having a heart attack. And I think the default is 0.5, where if it's above 0.5, then it'll guess yes. And if it's below, then it'll guess no. And if someone has a 50% chance of having a heart attack, or like 49.9% chance, we don't want to just say, oh, probably not. We want to still admit them. So right here, I changed that threshold. I changed the threshold. I also put it in a for loop. So I'm initializing the for loop here. And then I'm going to try every threshold from basically 0 to 1. And for each of those thresholds, we're going to predict and get the prediction here. And if it's greater or less than the threshold, then we'll assign it as necessary. So that way we can set the threshold to something that's going to be useful. So now, okay, and then at the end of the for loop, I'm just collecting all the data. Every time we go through the for loop, I'm collecting more data. Then here I put it into a data frame. We can see for all the thresholds what the precision and recall were. And I graphed it. So right here, you can see that the recall is really good right here. And it just goes down and precision goes up, obviously, because they are kind of opposites. So, I mean, this is kind of a moral question. Where do you draw the line? Do you say, I mean, obviously over here is a bad idea if you, yeah, that's just terrible. But right here, here's a couple possible spots you could draw the line and say, hey, if they have a 1% chance, even if there's even a 1% chance that they're having a heart attack, then we want to admit them. And you can see by this line, you would get almost everyone that's having a heart attack, and you would accidentally have about 75% of people, or you'd only be 75% of the people that you admitted would be having a heart attack, which means you were wrong a good chunk of the time also. So my suggestion is we would put the threshold right here so that we're at a 100% recall. And I mean, we're a little bit worse on our precision, but I mean, that's okay. It's, yeah, that's okay. If we admit 5% more people and waste their time, that's worth saving 0.5% of people's lives. So now we'll try it with the new threshold of 0.4, and we can see that our recall is 100%. We perfectly, every single person that was having a heart attack, we admitted them correctly. Unfortunately, 30% of people that were admitted actually weren't having a heart attack, but that's okay. So here again, it's worth getting to 100% and saving 0.7 more lives by admitting 5% more people. That's a okay trade-off. And then here I just used joblib to save the model. And here is some future work I'm going to do. I started doing some hyperparameter optimization and some grid searching, but I haven't had much success on that. So I'll work on that later. So that's how the model was built. And now we'll go through this. So this essentially takes, let's see, so each one of these functions is for a page. So this one is defining the home page. This one is the results page. So when we are on the results page, we want to load that model in that I saved. I called it heart model SAV. We'll call that CLS. And then we want to start a list, an empty list, and we want to append every parameter right there. And then we can do the same trick, change the threshold, get the, instead of just doing a straight predict, predict proba can help us get the actual probability for each observation. And then we can decide, hey, depending on if it's greater or less than the threshold, we'll assign it a 1 or 0. So that'll give us our answer. And then we also want to get the actual probability too. And we'll call that answer prob. And then we'll return all of that. And then that takes us to, well, maybe I'll go here, actually results. So the results page where it's displayed just says, should the patient be admitted? And then has the 1 or 0 likelihood of them, that they're having a heart attack, and then the likelihood. And then it returns a list also of all the data that they entered. And then here's a back button that'll take you to the home. The URL, or the home HTML looks like this. Looks a little bit messy. There's definitely a better way to do this. I was going to make it look pretty and then ran out of time. So I kind of jerry-rigged it. Basically, we're setting some stuff up. And then we're going to just have each of the features right here, and then they can, it's an input, so they can enter in text, and this is what it will be called. And then I needed to extend the bar to make it a little bigger. So that's how that works. And then this is the submit button. There's a data dictionary down here, just for my reference. Then I went over that. Okay, and then this just has the URLs. So when there's nothing there, we'll just go to the home page. We'll do views.home and call that function. And then if there's a result / at the end, then we'll call the result function. And I think that's pretty much it. It was a lot of fun to make this. And yeah, thanks for watching.